Hi and welcome back to the M5Stack official channel. I'm Luke and here we are continuing in the Stick-V series. In the previous videos we've seen how to get set up and how to mess around with the MicroPython API. In this video we're going to start to explore the specific purpose that the Stick-V AI camera was built for. You may have seen on the docs page this V-training icon. What exactly is V-training? In order to use facial recognition or object recognition on the M5Stick-V, first we need to train a model of the thing that we want the Stick-V to recognize. So how do we do this? A model is the product of creating a data set from multiple images and then processing it so that the AI can know the differences and similarities between those images. To get started, we'll need to extract the boot code files into an SD card. Unfortunately, not all SD cards are compatible with the Stick-V, so make sure to check the documentation for which ones are. After extracting the files to the SD card and inserting it into the Stick-V, we reboot the device by holding the left side button down for a few seconds. Once it reboots, we'll see the M5Stick training logo. The big button on the face of the M5Stick is for taking pictures, and the button on the right hand side is for creating a new class. We can see here on the top of the screen there is a banner across, which shows us how many pictures we've taken and what our current class is. The documentation recommends that we take a minimum of 35 pictures per object, and a minimum of 3 classes is required by the Stick-V training cloud platform. I would recommend, however, taking more than 1 class per object that you want to be recognized and taking more than 35, as occasionally these files can get corrupted or just don't appear in the folder. For a simple example of something we can train, I've chosen money. Here I have 4 different kinds of notes, and I'll take lots of pictures of them. Remembering to keep the objects in frame when taking the pictures, and assuring that the objects are adequately lit. Once we're done with taking all our pictures, insert the SD card into your computer, and let's have a look through some of those pictures we've taken. On the SD card there should be 2 folders entitled Train and Veiled, which I think should be valid. Within those folders you should find a bunch of numbered folders that should amount to the same amount of classes that you've created. We should check in each folder to make sure there's a minimum of 35 pictures in each, and that none of those pictures are corrupted. 1 or 2 of my photos were corrupted, and the Cloud V training platform will not accept this. But all I did was delete those corrupted images and replace them with duplicates of some of the others I'd taken, until there were 35 in each folder. In the veiled folder, it only seems to have generated 5 pictures in each folder. I found that this didn't matter as long as there was 35 in each of the folders of the train folder, and that there were a handful of images in each of the veiled folders. Then I was able to successfully generate a Kmodel file. Now this is definitely a trial and error process, and my success rate wasn't particularly high. Once you're done checking all of your images, make sure that you compress train and veiled into a zip. Note that it must be a zip. It cannot be raw or any other compression formats. Once we've done that, we go to the V-training site, which is linked to from the documentation. Here you must enter your email and then upload the zip to the site. It may take some time for the zip file to upload, depending on how many photos you had inside there. Once it's completed, you'll receive an email after a while notifying you of the success or failure of your Kmodel generation. I received quite a number of failure messages, which didn't always give me a straight answer as to why it had failed, but in the end I was able to generate a Kmodel. so this process does require a bit of patience. In the email you should receive a link which will take you to the download of a zip file. The zip file will include your trained Kmodel and a boot.py file which will automatically load that model once your M5Stick reboots. Let's place all of these files inside an empty SD card and reboot the Stick-V. As we can see here, it's starting to recognize the objects, but it gives each one a generic type 1, 2, 3, 4 based on the class. If we wanted to change that, all we need to do is to put the SD back in the computer, open the boot.py, and find the labels list. Here in the labels list we can change each type to whatever we want. Bear in mind it has to be fairly short or it won't fit on the screen. Now save the changes and pop the SD back in the Stick-V. Now I can see my custom message appearing when it recognizes the objects that I trained. The trained model works pretty well, just having some slight confusion between the 10 and 50 notes. What about training more complex objects though? I had an idea that I might put this in my garden and train it to recognize some common birds. I found a project on Hackster which talked about doing something similar, and also included a dataset from Cornell of many different kinds of birds. I replaced my pictures in the train and veiled folders with some of the pictures from the dataset. I uploaded this zip numerous times to the cloud platform, making changes each time, but sadly wasn't able to generate a model. Then I was thinking, I wonder if it's possible to use some pre-trained models made by others. Just like we placed our Kmodel files in the SD, it's also possible with others projects, and we can also write them to the internal flash memory. I've picked out 3 particularly notable projects here, which I'll leave the links to in the description below. The first one is Kmodel Selector by Misawa2048. It allows you to switch between Kmodels and also play sounds if an object is recognized. Although the recordings are in Japanese, I feel like this project is a good base to start off from. Next up is Brownie by ksasao. This project will say the name of the object in a cute voice when the object is recognized. It also has another interesting feature of using QR codes to train new models. The last one is from the Maixpy forums, which has a nice 20 class model which includes such things as sofas, TV monitors, bicycles, birds, cats. Let's see it in action here. And here we have Ksasao's project in action too. That's it for the video this week. Hope you found it useful. Please remember to like, subscribe, leave a comment, and I'll see you in the next video. Goodbye.